Welcome to online classes. I am Shilpa. We are discussing OOPS 3 C++ subject. In that, we are discussing what is meant by inheritance, what is the use of inheritance. In previous lecture, we discussed about different types of derivations and also about visibility modes. And in today's discussion, we are going to learn what are the different types of inheritances and how we can write or how we can inherit a single inheritance. So before going to that, what is meant by inheritance? Inheritance is the one which is used to create a new class from the existing class. The derived class is the new class and the existing class is the base class. So here the derived class inherits all the properties of the base class. And what is the necessity of inheritance? So the first necessity is concept of sensibility. By using inheritance, we can add features to an existing class without modifying it. We are not at all modifying the existing class, but we are going to reuse. We are going to reuse the code of the existing class. The class is already written, that is tested and using. So simply by reusing that existing class, we can add some other features to that code so that we will get another new class, that is derived class. We can derive a new class from existing one. And here the relationship between these two classes is close to the real world models. And also because of this transitive nature, that is, if a class A inherits properties of another class B, then all subclasses of A will automatically inherit the properties of B. Because of this transitive nature, the number of derived classes from the intermediate derived class are the class which derived from the original base class can acquire the properties of base class. So though here these derived classes are not directly derived from the original base class, that is in this case B, they can get, they means here all the inherited or derived classes of class A will get all the properties of B. So indirectly even the derived classes of already derived classes can get the properties of the base class. This is called as transitive nature. So that is again at any level using this inheritance, these derived classes can acquire the properties of the original base class or the first base class. When one class is inherited from another class, the code that provides the behavior required in the derived class need not have to be rewritten, that is, code be reused, which increases reliability. So when we are deriving and when we are adding some other features to the derived classes, we need not have to be rewritten. So here we need not to rewrite the code which is having the same purpose as the base class, because here as this derived class is inheriting from the base class, obviously it will get all the code of the base class into the derived class. So here we need not to rewrite that particular code in derived class. And code sharing can occur in several levels. That is what we discussed in transitive nature. Code sharing can occur at several levels. For example, at a higher level, many users can use the same class, and at lower level, code can be shared by two or more classes. So here, as we are using this reusability concept in inheritance, the code can be shared by two or more classes at lower level, that is at the time of developing. and after implementing and after releasing, here many users can use the same classes. Okay, so whenever they want to use the same code which is already developed and tested and released by some other project, they can make use of that code in their newly developing modules. When multiple classes inherit from the same base class, it guarantees that the behavior they inherit will be the same in all classes. Though here we inherited multiple classes from a single base class, here the behavior of these all classes, that means here the behavior of the properties or the features which they inherited from the base class. Okay, the behavior of the code which is inherited by this base class in all these derived classes will be the same. That code may not vary from one derived class to another class. The code which are the features which derive from the base class to these number of derived classes will be the same. Inheritance permits the construction of reusable software components. This is the main use or advantage of inheritance. It permits the construction of reusable software components. Using inheritance, one can concentrate on understanding the portion of the new system only. That is, here when we are deriving or when we are using this reusability code in our modules or in our code, then we need not to concentrate on already written tested code. That is the code which we are reusing in this module. We need to concentrate on only the new code or new portion of the code which we are now developing, because already this is reusability code which is already implemented and tested, and that is perfectly working. So when we are writing or when we are adding this particular reusability code to our new code, then we need not to concentrate on this particular portion of the code. Only we need to concentrate on the new portion of the code, so that we may concentrate or we may fully concentrate on only this particular new code or new that is the portion of the new code, so that we can effectively give the output. Okay, because though this particular module he is having so much of code, here half or some portion of the code is we need not to concentrate. Only we need to concentrate on a particular part of the code. This is another advantage of the inheritance. The development time is developing a system will be reduced rapidly. So as we discussed here, as some portion of the code need not be tested and need not be written. Okay, obviously we are reducing the time to develop the system. Okay, so these are the advantages of inheritance: reusability and reduce the time, cost. Okay, everything, even the that is manpower. Now, how this inheritance can be classified? What are the different types of inheritances? What are the different types of inheritances? So here mainly the inheritance is classified into 5 types. First one is single inheritance. Next, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. Single, multiple, multi-level, hierarchical, hybrid. So first one we will discuss single inheritance. First we will see the definitions of all these inheritance types, and later we will discuss each and every inheritance type with syntax and example program. Okay. So first one is single inheritance. single, the name itself. Single means only one, right? Single means the name itself you can infer one. A single inheritance contains only one derived class and one base class. Single means one. That's why in single inheritance only one derived class is derived from one base class. Okay. If you observe the diagrammatical representation, so here this is base class. This is base class which is used to derive a derived class. Only here we are deriving a single derived class from a single base class. Only from one base class. Deriving one class from one existing class is called as single inheritance. Okay. Next. Of course, if you remember in previous lecture, when we discussed this visibility modes, they without knowing, we use single inheritance concept. Single inheritance concept, that is the student class person, and we are deriving class student from the person. Okay, so that is we derive a single class, that is student from the single base class person. Without knowing actual this concept single inheritance, when we are learning, we learned is different types of visibility modes. There we use this single inheritance concept only. Now, multi-level inheritance. Always when we are discussing these inheritance types or categories of the inheritances, concentrate on the name itself. By observing or with the type of this inheritance name, we can able to know how it will be, how the inheritance will be. Multi-level, not a single level, multi-level. When we can say level, so normally for example, if you consider the steps, okay, this is, if you consider this is the first step, this is second step, third step, fourth step, fifth step, like that. That is here we can say levels. This is at ground level, first level, second level, like that. Here in opposite direction, because we are deriving a class from base class. Okay, so if you derive a single class from single base class, then this will come under level 1. This will come under level 1. And if you derive one more class from level 1 class, then this class comes under level 2. Level 2. And if here if you derive one more class, then that class will comes under level 3. Okay, this is the base one, and when we derive a class from the base class, then that comes at level 1. And when you derive one more class from level 1 class, then that is treated as level 2 classes. And if you derive any class from this particular level 2 class, then these classes will be at level 3. Okay, so this type of inheritance is called as multi-level, more than one level. So if we consider the single inheritance here, of course this is at what level? Level 1. Is it clear? Right? Level 1. This derived class is at level 1. But this is not called as multi-level inheritance. More than one level. It is having only one level, not more than one level. Okay. So single inheritance is not at all multi-level inheritance, because here it is having only one level, but here multi-level inheritance is the one which is having more than one level of inheritance. So this is an example, or we can represent that in a pictorial format like this. If this is the base class, and this is derived class at level 1, and this is another derived class at level 2 which is derived from the level 1 class. So this is an example for multi-level inheritance. If a inheritance type or inheritance is having more than one level of inheritance, then that is called as multi-level inheritance. Multi, more than one. Multi means more than one. Level means levels. If it is having more than one levels of inheritance, then this is called as multi-level inheritance. Next, multiple inheritance. Multiple. When we call multiple, if it is if more than one, then we call multiple. So here multiple inheritance. A derived class with several base classes. We are deriving a single class from multiple classes, more than one class. In single inheritance, we are deriving a class from a single base class. From a single base class. So this is called as single inheritance. In multiple inheritance, we are deriving we are deriving a single class from several base classes, not from a single base class. Multiple, from multiple to one. Deriving a single class from more than one base class is called as multiple inheritance. Multiple inheritance. So this is example, that is like this we can represent always when we are writing or explaining these inheritance types, then better to represent them in this diagrammatic representation. That is for a single inheritance like this, multi-level inheritance like this, and multiple is like this. What is the use of representing that inheritance in this like this? So whenever if everything normal as a human being, we can remember the things which we see than which we hear or by heart. Okay, if you see, we can strongly remember them in our memory. So here also, as we are representing these types of inheritance in a diagrammatic format, so by observing that particular thing, by particular diagram, you can able to know how to write the program. Okay, how to write, that is at the time of implementing code for this particular type of inheritance. You can easily write the code, that is if you observe this multi-level. So what you are going to do? So first I require one base class, and after that using that base class I need to derive one class, and from this derived class, because here we are deriving some other class from this class, so you need to declare or inherit one more class. So no need of you may not have any confusion. Okay, so only if you remember multiple without this diagram, if you remember multiple level, if more than one level of inheritance, then that is called as multi-level inheritance. Then at the time of implementation of code for this multi-level inheritance, you may confuse there. You may struck somewhere else. But if you also remember this diametric representation, so even you struck in the middle of a particular code implementation, then again you can go back and you can see this diagram, and you can easily come forward with your code. Okay, So this is the main thing when you are writing or explaining any of these inheritance types. First, give the definition of this particular inheritance type, and after that represent that inheritance type in diagrammatic representation, and after that of course we'll follow the syntax and example program. That is the best good way to explain about any type of inheritance. Okay, always this should be remembered by you. And about multiple inheritance, we are deriving a class, single class from several base classes. So this is one example for that is multiple inheritance. Like this, multiple inheritance can be implemented. That is, here we are going to derive only a single class, only a single derived class from more than one base classes. So in this case, I am taking only two base classes, but there is no restriction. Only the constraint is you need to derive a class from more than one base class. More than one base class. So here you can have any number of base classes. More than one base class. In this case I am taking two base classes, and from these two base classes I am deriving a single class. Okay. So like this we can implement multiple inheritances. That is, we need to derive a single class from more than one base class. That means here at the time of implementation, what we need to remember? First, we need to declare base class 1, base class 2, base class 3, like that as per our requirement. And after that, we need to derive a single derived class from all these base classes. Till now, that is at the time of visibility, discussing this visibility modes, we are derived a single class from a single uh, base class. Okay, but we are not at all seeing any syntax to derive a single class from more than one base classes. Of course, at the time of discussing this multiple inheritance, we will come across this particular syntax and how this derived class can be derived from more than one base classes. So this is multiple from more than one. We are deriving a single. Multi-level, deriving a class from it from other level classes, or having more than one level of inheritance. That is multi-level. Multiple, more than one, from more than one to one derived class. We are deriving a single class from more than one class. Next type of inheritance is hierarchical inheritance. So hierarchy also some may pronounce like hierarchy. Hierarchical inheritance. So hierarchy, as all of us know. So in every institution or in every family there is some hierarchy. Grandparents, from grandparents to parents, parents to child or children, like that hierarchy in if we consider the institution. Principal to heads, heads to senior lecturers to lecturers, like that. In every institution or everywhere we are having some hierarchy. Even at government offices there is some hierarchy. Okay, that is here the properties of one class may be inheritance by more than one class. One class may be inheritance by more than one class. That is, here one institution, okay, but they may have more than one branches. Okay, one principal but more than one heads. But because here we are having some number of branches, okay, or disciplines. So for each and every discipline we are having one head. From this particular head they may have some number of lecturers. Okay, like that. Some, that is here the properties of one class may be inheritance by more than one class. More than one class. That is, if you observe this, This is there is only one single class, that is base class, but we are having derived class 1, derived class 2 and derived class 3. Okay, that means here we are deriving multiple classes. Multiple means again more than one class, not a single class. Multiple, at least two. Okay, multiple classes from a single base class, then this type of inheritance is called as hierarchy. Hierarchy. So, deriving multiple classes or more than one class from a single base class is called as hierarchy. If you observe multiple deriving a single class from more than one base class. Deriving a single class from more than one base class. But in hierarchy, deriving more classes, that is more than one classes, from a single base class. From a single base class. If you observe, this may be opposite to this. Here from multiple we are getting single. But from here, from single we are getting multiple classes. So this is hierarchical inheritance. Hierarchy, principal to heads to number of lecturers. So here it is having some hierarchy like that. Okay, single to multiple. And from this particular class we can derive any number of classes. Okay, so this is hierarchical inheritance. And last type of inheritance is hybrid inheritance. Hybrid inheritance. So here hybrid, what is meant by hybrid? By combining some different types of inheritances. Okay, hybrid normally when we are normally using hybrid plants, so they take different plants and they combine those different plants into a single plant, so that this hybrid plant may get all the features of all these multiple plants. Okay, so hybrid inheritance, that may be at any level. First, they may take only two plants, and after getting hybrid from these two plants, they may add a normal plant again, that is the original one, and combining this hybrid and this original, they may go for another hybrid plant. Okay, so like that we may have any combination. So here not specifically this is a combination of multi-level and multiple inheritance, that is not the actual thing, but in some books we are having this particular definition for hybrid inheritance. But the actual definition of hybrid inheritance is the combination of any of the discussed inheritance types. At least two inheritance types. The combination of any two inheritance types is called as hybrid inheritance. That may be a combination of single and multiple, multiple and hierarchical, okay, or multi-level and multiple. Any combination, not particularly here multiple and multi-level. And if you combine this, this is called as, I think, multi-path. So if we consider this, this is not the actual definition of hybrid inheritance. Hybrid inheritance is the one that is the combination of any two different types of inheritances is called as hybrid inheritance. Combination of any two inheritance types, or two or more. Any two or more inheritance types is called as hybrid inheritance. And the combination of multi-level and multiple inheritances. This is also hybrid inheritance. The combination of multi-level and multiple, because here what we are doing, we are combining two different inheritance types. That is, first one is multi-level and second one is multiple. We are combining these two inheritance types. So this is an example for hybrid inheritance only. Okay, and here in this case, if you observe multi-level and multiple, so here if you consider this part, only this part. Okay, so this is an example for which type of inheritance? Multi-level inheritance, right? Base 1, base class 1, base class 1 to derived class 1, and from derived class 1 to derived class 2. So if you consider only these three classes, then it is an example for multi-level. And simply omit this particular base class 1 and now consider these three classes, that is derived class 1, base class 2. Here derived class 1 and base class 2 are at the same level. Okay, and we are deriving derived class 2 from these two classes. Okay, if you consider this is an example for which type of inheritance? Which type of inheritance? Multiple inheritance. So the combination of multi-level and multiple inheritances is called as multi-path inheritance. Of course, this is an example for hybrid inheritance also, but particularly it is also called as example for multi-path inheritance. Multi-path inheritance. Multi-path inheritance. Okay, this is also called as multi-path inheritance. This is an example for hybrid also, but particularly it is called as multipath. Why it is calling as multipath? Multipath means what? More than one path. More than one path for what? For derived class. More than one path for derived class. That is from base class 1 to derived class 1 and from derived class 1 to derived class 2. This is one path. In order to reach this derived class, we can reach from base class 1 to derived class 1 to derived class 2. This is one path. And directly here we are having one more path, that is from base class 2 to derived class 2. So this is an example for multi-path inheritances. In some books, as here we discussed only 5 different types of inheritances, that is single, multi-level, multiple, hierarchical, and hybrid. And hybrid, we mainly categorize the inheritance types into 5 categories. But in some books they are including even this inheritance, that is multi-path inheritance, as another category of inheritance. Multi-path inheritance. But normally this multi-path inheritance is a special case in hybrid inheritance. This is a special case in hybrid inheritance. Okay, so you can say this multipath inheritance is a special case in hybrid inheritance. But hybrid inheritance means not only the combination of multi-level and multiple inheritances. Any combination of any of two different types of inheritances. Combination of any two different types of inheritance is called as hybrid. Okay, and specifically the combination of multi-level and multiple is known as multi-path. Okay, these are the different types of inheritances. Okay, and when you are that is discussing, or when you are going to explain about these types of inheritances, first one you need to define that particular inheritance, and after that you better to represent in that is diagrammatic representation. Now we'll discuss in detail each and every inheritance type. The first inheritance type is single inheritance. As we discussed, that is, as we see the definition of the single inheritance, a single inheritance contains only one derived class and one base class. That is, deriving a single class from single base class is called as single inheritance. And The declaration of derived class is same as ordinary class. So when we are declaring a single derived class, the declaration is same as the ordinary class. And a derived class contains of the following components. So when we are declaring a derived class, it is having some components like the keyword class. It should have, and the name of the derived class. It should have a name for this particular derived class, and a single colon, and a single colon and followed by the type of derivation, okay, and the name of the base or parent class, and after that the remainder of the class definition. So when we are deriving a single class, then it is having some components like first the keyword class, the keyword class, and after that name of the derived class, and colon, and visibility mode. We discussed already visibility mode, that is either public, private or protected. That is the type of the derivation we need to specify here, followed by the name of the base class from which we deriving this class. So name of the base class followed by its definition, that is open curly brace, and its definition and close and semicolon. Okay, it is having these components at the time of declaring a single inheritance. So this is after define that is providing definition and writing about the components of a single inheritance. Immediately we need to represent in a that is diagrammatic format. So here we need to represent like this, deriving a single class from the base class, and after that the syntax for deriving a single class from the base class is as we discussed. It is having these components, that is first one is the keyword class, followed by derived class name, colon, type of the derivation, that is we need to represent or write the visibility mode, and base class name, and base class name. Okay, colon and base class name, visibility mode and base class name, and its members and member functions, data members and member functions, that is the definition of this derived class. Okay, so when the compiler observes this particular statement, it came to know that this derived class is derived from the base class in this particular derivation, that is either private, public or protected derivation. Based on this particular derivation, the compiler allows the derived class to access the members of the base class. Based on the type of the derivation, here the compiler allows the derived class to access the members of the base class. Though the derived class is derived from the base class, this derived class cannot access all the members of the base class. Of course, it cannot access the private members by default. Okay, and after that, by observing the this derivation type, here the compiler decides which members of the base class can be accessed in the derived class. Okay, now example is, if this class A is the base class, okay, it is having its own members, and here when we are deriving the class B, here we are using the keyword class and followed by the name of the derived class, that is in this case B, colon, and the type of the derivation, here public derivation, and the name of the base class, and followed by all the members of the derived class B, members of derived class B. So here we will see one example program. Okay, here we are having one class student, which is having some data members like name, age and gender. Okay, and here they are having get data uh, of base. So better, I think. Let me, okay, here's some modification. This is student and this is person. Okay, because always the person may have name, age and gender, and the student may have roll number and pin, like that. Okay, so this is person in general. This is a name, that is person, and the person class is having name, age and gender, and it is having some member functions like get data and display. And here this get data base function is used to get values for name, age and gender, and display base is the function which is used to display the values of these variables, that is name, age and gender. So for that, here we written the code get database, so it reads values for name, age and gender, and display simply displays name, age and gender. Okay, this is only the base class. And here we are deriving a class, that is student, from base class, that is person, in public derivation. Yeah, deriving the class student from the class person in public derivation. And here the student is having two variables. In this case are two members, that is one is roll number and another is char branch. Okay, so here we are having some member functions, that is get data. Same I am using get data for even here, but I am specifying that with get database, and I am distinguishing the functions of these two with base and derived. That's it. Get data derived. Okay, it is calling get database, that is internally it calls get database, so that here it asks us to enter name, pin, sorry, name, age and gender. Get database we are calling in derived class. Get database in get data derived. So here it asks us to enter name, age and gender. And along with those three, here it asks us to enter roll number and branch. See, if you observe the code for reading name, age and gender is not written here. That is in the part of get data derived function. That is written in the base class, but we can able to read or call that particular member function in derived class. So that here we are reusing the code, that is get database functions code, in this function, reusability concept. Okay, like that even for display derived, we are calling display based base, and along with that we are displaying roll number and branch of this derived class. Okay, and in main simply we need to call create the that is object for derived class, that is in this case that is student. We are derived student from person, so we are going to create object for student, and using this s we need to call get data derived only. Okay, and also display derived, display derived. Okay, so that here it calls student s is the object which is created for the student class, and using that s we are calling get data derived. So here it comes to compiler comes to execute this get data derived, but here it is calling get data base, that is the base, and it checks whether this get data base is accessible in this derived class or not. As this get database is public, here it calls this particular code, and it reads values for name, age and gender, and after completion of that it executes these statements, that is cout, enter the roll number and enter the branch, and it reads values for these two, and after completion of that in main we are calling as data display derived, so it comes to display derived, and here again it is calling display base. So it jumps to display base, and of course first it checks the accessibility, whether this display base is accessible in the derived class or not, and after checking it calls this display base, and it displays name, age and gender, and after completion of that particular statement it jumps to next statement, or it executes the next statement, so that here we will get roll number and branch. And after that simply in main no other statements, so we will get the out. Okay, like this the single inheritance program can be implemented. Okay, we will discuss that is the execution of this. We will see the execution of this single inheritance type in the next lecture. Thank you.